Namaste. In this session, we will look at the precision recall curve and its area under the curve. Now, PR curve is a function of precision on the y-axis and recall on the x-axis. So my recall is basically out of all the times that the real class was positive, how many times was I correct, and precision is out of all the times that I predicted positive, how many times was I correct. Okay, so these are the two metrics which we will be using in this PR curve. Now here, for different threshold values for a particular classifier, we'll get different confusion matrices, and for each confusion matrix, I can calculate my precision and recall, right? So I'll do it for each and every confusion matrix here, and I'll get my precision recall curve. Well, what does my perfect classifier look like on a PR curve? Well, it looks something like this. So a perfect classifier will have precision equal to 1 and recall equal to 1, because my perfect classifier will not misclassify any data to be negative or misclassify any data to be positive. Okay, it will only correctly predict the classes, and hence my precision and recall will both be equal to 1. So this is the point that I am looking for, the point of 1 comma 1, which is precision 1 and recall 1. And since my recall is going from 0 until 1 and precision is going from 0 until 1, my area under the curve is 1 square unit, or just 1. So my maximum AUC can be 1. Now you must be wondering, when can this be the case? Well, just imagine if I have 6 people in the test set, and out of those the first 3 people do not have a particular disease, if we are talking about a medical case scenario, and the next 3 people have a disease. Okay, so these are ones and these are zeros. Now if my model is so good that it is predicting for the first 3 people that they have only 1% chance of having the disease, and these people, the next 3 people, they have a 99% chance of having the disease, then our model is basically very good, right? Then at any particular threshold value, if you check, a model will not make any mistake. So, and hence I'll have precision equal to 1 and recall is equal to 1. Now when I say at any particular threshold, basically under the hood, the thresholds will be chosen by looking at the unique number of probabilities. Okay, so I have only 2 unique probabilities here of 0.01 and 0.99. So these will be the 2 threshold values which will be chosen for creating the confusion matrices. So I'll have 2 confusion matrices and the precision recall curve will be drawn in that way. Now if I have 3 different classifiers, okay, so my classifier C will be the best one out of these, because it has the highest area under the curve, and also it is closest to this point of 1 comma 1. So the closer a classifier is to this point of 1 comma 1, the better it will be. So my classifier A will be the worst one and B will be the middle ground between C and A. Now the baseline PR curve area under the curve is given by the total number of positive samples in the data divided by the total number of data samples which I have in my data. So if I have 100 data samples in my test set and only 20 of them happen to belong to the positive class, then my baseline AUC will be 20 by 100, which is 0.2 or 20%. So with this 20%, I can judge my classifier whether it is any good or not. So if I have an area under the curve in this PR curve of 0.25, then it will be a very bad classifier. But if I have, for example, 0.5, 0.6, 0.7, it will be a very good classifier. Now let us compare ROC curve and PR curve and when to use which one. Now in a hugely imbalanced dataset, if we have a very high number of true negatives, then if you look at this formula for the false positive rate, which is my x-axis on my ROC curve, my number of true negatives will be a very huge number, because my dataset is very hugely imbalanced, and hence my false positive rate will be a very small number. And if I have a very small false positive rate, then my curve will basically look something like this, and this will basically imply that my area under the curve is very close to 1, which will be a bit misleading, because this curve is not due to a classifier being very good, but due to the data having very hugely imbalanced classes, and hence ROC curve should not be used when we have a severe class imbalance in the data. Now PR curves have precision and recall values on the axis of the y and x axis, and precision and recall, they do not make use of the true negatives at all, and hence they become very much suitable for such analysis where the number of true negatives is very much huge, or when the existence of the true negatives doesn't really play a major role in the business problem. For example, in information retrieval systems, the number of true negatives does not really matter, because we are majorly concerned with maximizing the number of true positives. So I hope now you have a clear understanding of what a precision recall curve is and what the area under the curve is, and when to use a precision recall curve and when to use a ROC curve. So that would be all for this one. So thank you for watching.